Hi, this is Lavarier channel. This blog is my English learning journey. What is ownership in Rust? Last time I tried to compile this code but failed. Look here. String type into message variable and message copy to message 2, and then I used a message variable in print line. Let's compile. I get an error message. I will try to explain this mechanism this time. Rust has an ownership mechanism that implements of RAII pattern. RAII is resource acquisition in initialize shorten. What is that? According to Wikipedia, resource acquisition must succeed for initialization to succeed. Thus, the resource is guaranteed to be held between when initialization finishes and finalization starts, and to be held only when the object is alive. It's not easy for me to understand. In other words, the allocated memory should be free after use. Very simple. If I should do it, the program makes it easy to leak memory. And also, the official document wrote Rust to make memory safety guarantees without needing a garbage collector. Rust implements ownership to achieve this mechanism. I will write a C language that samples the program of memory allocation. I prepared it. This one. Simple code. It allocation memory when I call an input text function. Input text function is here, and I called it here. Input text function is allocate memory and scanf, and call scanf function get some input and return that allocated memory pointer. And then I copy the pointer to other variables ref1 and ref2. Look here, ref1 is copy input. Ref1 is input pointers copy. Ref2 is ref1 pointers copy. そんな感じ。Should I call a free function for those variables? I should free only an input variable because the ref1 and the ref2 are copied from an input variable. If I free other variables after that, I try to free a released pointer again. It's called a dangling or wild pointer. So dangerous operation. But the C compiler cannot reject as errors in those code. Try to compile this code. Okay. It has no error. And execute this code. Okay. Yeah. Come on. It's crash. Why crash? Look here. I free always already free pointer. So my program is crash. I didn't do this. Save and build again and execute it. Perfect. However, Rust cannot do it because the compiler output an error message when I load it. Let's look at the beginning program code again. This one. The ownership moved from one message to a message to variable. Here. At first, message variable has ownership, but this code moved to message to this string typed ownership. So message variable has no ownership. Because print line with message is error, I couldn't use a message variable when I called the print line, this line. The ownership move also happened when I called some functions with variables. Only a single variable can have ownership in Rust. So, Rust can automatically free of memory when existing from a variable scope. In other words, Rust is a memory-safe language without a garbage collector. Great. Anyway, I will write some program code to check ownership behavior in the Rust compiler. First of all, I will create a simple string output function with generics because I want to use a string type and slice type. Okay, let's get started. And then I will use it to check the ownership. Clear message, save and compile, and execute. Helloだけあれや 3 time output. I call print string 3 times. Here, here, and here. Perfect. This code is correct, even if I get a copy variable, because I use only a slice variable in this code. According to the Rust book, slices let you reference a contiguous sequence of elements in a collection rather than the whole collection. A slice is a kind of reference, so it does not have ownership. Yes, I use slice type. Slice type does not have ownership, so copy to SL2. After that, I can use SL and SL2. Makes sense. Okay, next, I have a question about the print line. Why can print line sometimes call with string type? Apparently, a print line is a macro, not a function. What is a macro? The macro generates Rust code before compiling the target code. The macro isn't a function. I will make a don't do anything macro. Okay. I'm not generate some code in this macro. And then I use it, remove this code, this macro can use some arguments. So I use a message variable in 3 times. And then I call print string with message variable. Clear and save and compile. Here, hello Takeharaya. This is here. I already use message variable in the macro, but I can use message variable with print string function. So print line can use message string type over and over again. How about this? I called an empty macro repeatedly with a string type variable, but it didn't have an error. Anyway, I wrote a print string function at first. It returns the value what an argument string variable. So I declared a mutable string type for use after function call. Okay, next code. I call here, and I reassign string value to same variable. Save and execute. Empty macro. Okay. Delete this. Compile again. Yeah, look here. Reassign string 3 times. Here, here, and here. But I delete this code and compile and execute. Here, move. Value moved. So I have an error message. This code is correct. This code reassigns a return value to variable so that I can use it after print line function. Finally, I use a custom struct type to confirm ownership. Okay, save, build. Oh, sorry, I have an error message. What? No error. I can do that. Look here. This line is here, and finish is this one. What is dropped S? I implement a drop rate for S struct. So this is not easy to understand. This is not okay, but look this order. Finish after drop S, but I create block scope here. This one. Okay. Try it again. Look here. S dump after drops and the last finish. Print line finish. This means S struct S variable drop from memory when exit that variable scope automatically. Okay. The derive attribute work for the formatting of a print line macro. This one is for format this. I get a compile error when if I don't reassign the return value from a modify as function, and I implement a drop rate so it automatically removes from memory when existing a scope. Here, delete and save. After that, I got error. Value borrowed here after move. Struct S variables ownership move to modify S functions argument T. So I use after that I use S value. But here I got error. It does not have ownership. So reassign. So I use this code. This one is modify S return argument value return. Argument value return. So I can reassign to variable save value. Okay. まあそんな感じですよ。Okay, that's it. I learned that the ownership mechanism is important for memory safe programming in Rust language. Thank you for watching. If you enjoyed this video, please hit like and subscribe. See you. 難しいよ。英語で説明するの。日本語だったらすごくわかりやすく説明できる自信がある。これ。Bye.